So to understand the third part of the lab, you have to really think about the equilibrium that's happening in this system. In the first two parts of the lab, we forced this reaction to go all the way to the right because we had an increased concentration of iron. In the second part of the lab, we have a smaller concentration of both of these ions. So there actually was an equilibrium established where some of this reacted to make this, but then there was also some of this that remained. So in the third part of the lab here, we're going to be able to calculate the equilibrium. We kept the concentration of the iron constant, the initial concentration of the iron constant throughout the third part of the lab. What we changed was we added a little bit more of this every single time. And with a little bit more of the thiocyanate, we saw a little bit more red color, which makes sense mathematically because the equilibrium constant is the concentration of the products over the reactants. So in this case we have iron thiocyanate and thiocyanate, so thiocyanide. So what we were doing is this value was staying constant. As we increase this, we would expect to see more of the products as well because it has to equal, the ratio has to equal the equilibrium constant. So if we increase this one, this has to also increase because the ratio needs to be constant. And we saw that because your test tubes gradually got darker red as we went along. So from here, we had to do some thinking. The first thing we had to determine was the concentration of the iron thiocyanate. And you did that in number 3, and you can do that using the line of best fit. The absorbance equals so where the absorbance is basically the only colored substance is absorbing. Only the colored substance is absorbing light. So we can figure out the concentration of the colored substance, which is the iron thiocyanate. So you can do that by substituting. Where it gets tricky is the concentration of the other two. So in number 4, we have to determine the concentration of the iron and the thiocyanate. We can find what we started out initially before the reaction went to equilibrium. We can find that because we know that M1V1 equals M2V2. We started out, our first molarity was 0.002, and we put 3 milliliters, 0.003 liters. And we diluted that to the new concentration, and we also diluted every test tube to 0.01 or 10 milliliters. So we could determine that the amount of the initial concentration of iron was 6 times 10 to the negative 4th molar. And I'm not doing sig figs right now, so you guys can worry about that in the lab. So that's what we started out before the reaction happened. When we added the thiocyanate, some of this iron got used to make the iron thiocyanate. So the last part of your calculation that you have to do is you actually need to subtract out whatever the iron was that went to make the thiocyanate. And that's going to tell you how much iron, what's the concentration of the iron at equilibrium. Okay, oops, sorry, I don't know if you can see that or not. So subtract out the iron thiocyanate, and that's going to tell us the concentration of iron at equilibrium. And to do the concentration of the thiocyanate, you do the same thing. We're still diluting to 10 milliliters, so I think I made a mistake in 5th period. I said you could use the pre-lab, but you can't because the pre-lab was for diluting to 50 milliliters. So here we're diluting to 10 milliliters, but this number here is going to be For test tube 2, it will be 0.002. For test tube 3, 0.003. For test tube 4, 0.004. And every time you're subtracting out the corresponding iron thiocyanate concentration. The last thing that you need to do is you have the concentrations, so you just substitute to the equation products over reactants. And it's a 1-to-1 ratio, so you don't have to worry about raising it to the powers. And you should get some values for K, and they should be close to each other, but judging from our other numbers, they probably won't be, but they really should be close to each other. So we'll see how that goes when you guys get through the calculations. Okay.